Okay, we've got 14 on the webinar. We'll go ahead and get started. My name is Greg Hyde. I'm the product manager for JMS Biohandling, and we're going to talk about belt conveyor basics today. Previous to JMS, my background was screw conveyors, and in the screw conveyor business, everybody likes to say that you don't want to use belt conveyors, that they're old technology and dirty and not enclosed, and you want to use a screw conveyor. And after I got to JMS and learned a little bit more about belt conveyors, found there's definitely good application for belt conveyors, and they are definitely being used currently and will be in the future. And belt conveyors represent about 50% of our revenue on the conveyor side of our business. And in fact, belt technology is newer than screw technology. So we'll look at belt conveyor basics today. We're not going to go into real deep dive on the details, but we'll certainly cover the basics. And we've already got started here, but we hadn't gotten too far. So belt conveyor basics today, we're going to look at advantages, product application, selection and details of troughing and sidewall belts, competition, and more. As we know, product will get deposited onto a belt conveyor in the inlet or impact area, and it will rest on the belt as the belt itself moves up to the discharge point and is discharged. The product itself is static on the belt. Only the belt is moving, as opposed to a screw conveyor where you've got product turning over every pitch of the screw and being agitated. And one of our primary applications for belt and screw conveyors in this industry is sludge, dewatered sludge. And as you probably know, sludge is thixotropic. When you work it, it tends to change properties, and it will, after X amount of feet in a screw conveyor or X amount of incline, it gets worked to the point that it turns into kind of a gloppy paste, which is okay sometimes, but sometimes it's not. And because a belt conveyor doesn't have that agitation or turnover action, and the product is not mixed or disturbed, and it stays in a fairly stable cake form, and in certain applications in the wastewater treatment industry, this is very desirable. We'll talk about that a little bit more later on. Another advantage on belt conveyors is almost unlimited length. The longest belt conveyors in the world or longest conveyors in the world are belt conveyors. I think my Google search showed one that was 19 miles long in the ag business. Also, low energy consumption. Definitely when you compare what it takes to move product in a screw conveyor versus a belt conveyor, you're going to use less horsepower in a belt conveyor. High capacity applications. Again, we look at, and I'm comparing this to the ag business because in mining and stone, they use belt conveyors almost exclusively, and I'm bringing that up because they use very high capacities and long lengths. So low energy and high capacity is important to them, and that applies in the wastewater treatment too. And while we're talking about high capacity here, just so you know, the typical belt speed in our industry is 100 feet per minute, which is about walking speed. It's relatively slow, and it can be anywhere from 50 to 250 feet per minute. The ag business, where you've got higher volumes and higher capacities, they may be traveling 600 feet per minute. So you can see how some big possibilities in the belt conveyors as far as whereas you would have limitations in screw conveyors in getting those kind of capacities. We look at the cons on belt conveyors. Belt conveyors are hard to enclose. We do some covers that for weather coverage, which we will see later on in the slides. But if we need to enclose those for odor control in a plant, it's a little bit more difficult, not impossible. They also require a certain degree more of cleaning than screw conveyors, some spillage and some housekeeping issues that need to be addressed on the belt conveyor. As far as layout and flexibility of design, belt conveyors are just as flexible as screw conveyors. In some cases more so. We do the same things that we do on screw conveyors, from simple horizontal to incline, even horizontal to incline, and back to horizontal if we need to on the sidewall belt. We can also automate the belt conveyors like we do the screw conveyors with either center pivot point. This is where a product would be dropped in the center of the belt conveyor, conveyed to one end, and rotated to fill, say, a dumpster on this side. And when that dumpster was full, we'd reverse it, take it over here, pivot the entire conveyor to fill a dumpster on this side. Here is another automated belt conveyor, and this has a pivot point on the tail end. And we've got driven wheels that turn the entire belt in a radius, and this is typically for stacking for sludge storage, typically in covered or yard storage for pickup later. And the shuttle conveyor, which is also automated, which can move from side to side and fill a dumpster or a truck below. And we'll look at application of belt conveyors. The application of trough and sidewall belts are the same as far as product, and we've got a little matrix here, and you see a top row up here. We've got products that we typically see in water and wastewater treatment plants. We've got sludge, lime sludge, raw screenings, compacted screenings, macerated screenings, and dewatered grit, as submerged is obviously not applicable for a belt conveyor. And on this column here, you'll see that we've got troughing belts and sidewall belts, and how these apply to these different products. About 80–90% of what we do is dewatered sludge with belts. Do some screenings and some dewatered grit. The drawback on raw screenings is that it can rag on the wiper of the belt, and it does take some attention to make sure that stays clean. If you get to macerated screenings, that's less of a problem, and it's a good application for that. And we look at some of the prime applications for belts. We talked about maintaining the integrity of the product on a belt conveyor. This is important in where you've got a sellable product, where you can dispose of your sludge in a manner that there is a market for. And that would be typically post-THP process, lime stabilization, or feeding an incinerator. Also, long conveyors, as we talked about before, they're almost unlimited in length. And those are typically troughing belt conveyors, and also tight layouts, which are typically sidewall conveyors. So all things given equal up here on the product side, it's typically the belt layout that decides which type of belt that we're going to use, either the troughing or the sidewall. Let's take a quick look at the difference in overview here, then we'll go into it a little bit deeper. On the troughing, we have a flat belt that is formed into a trough profile by idlers, These are what we use typically for the long conveyors because the flat belt cost is about 1/10 of what the sidewall belt costs per foot of belt. Also, you can use multiple drop points on a troughing belt. We'll see that further in the slides where we go from troughing to flat and use plows for multiple drop points. The sidewall typically used in tighter applications where you need to utilize that horizontal to incline. You could stop at incline or you could carry it on horizontal. And you see this is done, this multiple planes are done with one drive. So in a screw conveyor application, this would replace 3 separate screw conveyors with one belt conveyor. And because we're using one drive instead of 3, that's going to be more cost effective than using 3 screw conveyors. So we'll look at the cross section here in a little bit more detail on a troughing belt. You'll hear trough belt, troughing belt, troughed belt kind of interchangeably in the industry. So we've got the flat belt that is formed into a trough profile here by the carry idlers. The carry idlers are what we call the top idlers. On the top side of the belt, we've got a horizontal roller in the middle, and the outboard rollers are at 20-degree angle. These are, this is a SEMA standard, and SEMA is the Conveyor Equipment Manufacturers Association, which we belong to and we manufacture to. This means that our components are interchangeable with any U.S. SEMA manufacturer. So these are SEMA Type C 5-inch diameter urethane carry idlers, which is the wastewater treatment and industry standard right now for carry idlers. So we've got the carry idlers forming the belt. The frame of the belt conveyor is just a simple C-channel frame on each side here, which we cover with a deck plate here. You see the deck plate and the idler brackets. The deck plate purpose is to keep any spillage or carryover from dropping down and hitting the return side of the belt. So the return side of the belt, you'll see the flat return idlers holding up the return belt. And typically these return idlers are on about 10-foot centers. Your carry idlers are going to be 3 to 4 foot centers. And in impact areas, 1 to 2 foot centers, or you may even have something that are called impact bars in lieu of multiple idlers in an impact area. Going back to the profile here, we've got the drip pan underneath the return side, and this is simply to carry, catch anything from the return belt that might drop to keep it off the finish floor. These drip pans can even be finished with, or typically supplied with drains, and optionally with wash down nozzles to automatically spray water to the drains. You can see the some electrical here. This is a typical e-stop switch, which is furnished with on both sides of every belt conveyor. Other electrical that would be applicable here would be a speed switch, just like on a screw conveyor. Of course, the motor drive, and depending on the length of the conveyor, we may have some misalignment limit switches outboard here to indicate if the belt is not tracking properly. So that's kind of a good cross-section view of what makes up a belt conveyor. The only thing you're not seeing there is the head and the tail pulley. We'll see that a little bit later. This profile is the same for sidewall belts, except for the idler and the belt profile. So we'll look at that in just a second. Right now we're going to look at some drive details. Typical old school drives are the chain and sprocket or belt and sheave. Given the choice, we prefer to go to the chain, but more often now we are going to recommend the direct drive, which eliminates the chain and sprocket over here, which is a point of maintenance, less maintenance less worry-free over here. Here are a couple of other less utilized drives. This is a motorized drum pulley. So this is a head pulley on the conveyor, which actually has a motor inside of that pulley. It's quite expensive. Don't use it very often, but we do have some plants that prefer that. Detroit being one of those, which we've supplied many of these. These things are a bit more expensive than a typical drive by a factor of 2 or 3 times sometimes. This is a center drive, not well shown here, but basically this is a center drive on the return side of the belt in the center of the belt rather than the head pulley. And we utilize this when we've got long reversing conveyors. A few more details here is, again, here are the troughing idlers. And the JMS standard is to use stainless steel on frame, supports, deck plates, drip pans, and skirt brackets. You will also see that specified as hot dip galvanized or painted. For the small difference in cost, we just prefer to go 304 or 316 as specified. I've already talked about the idlers. Typical would be painted or galvanized. We make our own stainless steel idler frames here. Another option is belt plows. If this would be a troughing belt that would go from troughing idlers to flat idlers just before the plow, so that we can actuate the plow down to a flat belt to discharge either to another conveyor or into a container. Another option is a wash box. This is a box on the underside, return side of the belt, where the belt would come through. Spray nozzles would hit the belt. A wiper downstream of the nozzles would clean the belt, and then additional nozzles will wash out the bottom of the box to the plant drain. Here are some cover options that we have, from 75 to 100% coverage. And these coverage are for environmental weather protection. They're not for odor control, and I'm referring to these over here on the right side. Here's a long conveyor we did in Wilmington, Delaware, and a wastewater treatment plant there. You see, that's 100% cover. Most covers have a hinge section so that they're accessible from one side. The typical material on that is going to be hot dip galvanized or stainless steel. I mentioned that it's a little difficult to completely enclose for odor control. This is one of a couple that we've done for odor control purposes, and you can see there's quite a bit of work that goes into covering that up, and quite a bit of work that goes into accessing everything that you need there. I think that one looks like it's got a wash box too, and a lot of different options on it. And we'll look at some typical troughing belt layouts. This is a troughing belt going from a belt filter press up to a lime mixer. This is one of those applications where they want to keep the integrity of the sludge before they put it into the lime mixer. We've used just a simple troughing belt here at a 16-degree incline. We could do this with a sidewall, go horizontal to incline to horizontal, but this is a less expensive way to do it because we could do it with a troughing belt. Here's a troughing belt that goes from a dewatering device down to 4 other cross collectors with multiple plows. So we've got a plow at each intersection here to dump off into cross collector number 1, 2, 3, or 4. The cross collectors are reversing, so they can discharge off the head end, the tail end, or at either of these 2 plows. So we've got 4 bays, 4 discharge points each. I'm not sure if this is a truck loadout or it could be for inside storage. Here's another good troughing application we did in Dallas, Texas. You can see, even though this is troughing, it has has a bend in it here. That's called a radius curve, and we can bend a troughing belt if it is slight enough. This has to be a 150-foot radius or greater. Otherwise, if we try to go too tight on the radius there, what happens is the belt will lift up off of the idlers. That's why we have to stay at 150 feet plus. To do that, in this layout, it was a perfect application for a radial curve because we've got the space to make that gentle curve, plenty of space, and we go up and we actually make another gentle curve back to discharge onto a reversing conveyor up here. And we'll take a look at sidewalls here. As you can see, same basic profile on the frame, except for the straight or flat carry idler, and then the profile of the belt is flat. So you got a flat belt with corrugated sides to contain your product since you can't trough this. Here you can see the corrugation and the belt. This belt comes out flat beyond the corrugation so that we can hold it down in this transition area right here. That's how we can do a higher degree of incline on a sidewall, is because we have, here's a cross section of the rollers. There's a number of ways to do this, but you can have cantilevered snub nose rollers here, or you can have the axle through with two big rollers. But our rollers hold the flat part of the belt down during the transition. Here's a better view of that belt, the sidewall belt with the flat part coming out here. This conveys material up the incline, and as you go over the discharge point, you got the gravity fall, of course, then you've got a wiper that cleans this belt on the bottom side. Here we've got a cleated sidewall, and the reason we use cleated is because when we get to 25, 30 degrees or greater, we're going to have to use cleated. This is actually a very short cleat and very far apart. Typically they're higher, they're closer together to carry, not sure what this product is, but sludge would require more cleats, higher cleats, and you can see how high the corrugations are on this sidewall. This belt gets pretty expensive, and we really don't like to use a cleated belt just because that tells us probably retrofitting, because there's not enough room to go at a 25-degree incline like we want to. For some reason, we had to go steeper. And the reason we don't like to use cleated is a wiper can't clean this belt when we've got cleats. So we have to use what's called a thumper, which after that belt goes across the head pulley and deposits sludge, we've got a mechanical thumper underneath there that's just basically hitting the back of the belt to try to clean that belt out. So you're going to have a little bit harder time keeping that belt clean. And we'll look at a few typical sidewall applications: horizontal to incline to horizontal again. This was probably a retrofit, I'm guessing. We've got belt filter presses, very low down elevation, so that we had to get down underneath that and get up and over, provide a clearance here for a truck and still drop in. This would have been a difficult application for conveyors because of this transition point being so low, and maybe even problems with the headroom up here. Here's a couple more, horizontal to incline. This one has covers. There's probably a wall right here. Another horizontal, incline, horizontal. And this one could have used a radial curve on the troughing, but we had a truck lane here that we had to clear. So that's when we went up steeper with a sidewall rather than a troughing. Just want to mention briefly, you see that phantom circle there? That's the travel for the tail pulley. We keep a take-up in the tail pulley for belt tensioning. Okay, we'll look quickly at JMS and competition. We feel that JMS is the leader in material handling and wastewater treatment because the engineering involved and the experience that we have since the the 1960s in this industry. We've got a complete line of material handling, belt and screw conveyors, including shafted and shaftless, storage systems, gates, and different system configurations. Our main competitors in wastewater treatment are Custom Conveyor and KWS. So if we're asked to name a competitor, those two would be primary. JDV and Keystone, a lesser player in the belt and conveyor industry. We see dewatering equipment and screen manufacturers offer conveyors, but typically they're buying that out from another conveyor manufacturer, and that may be somebody in Canada or Italy. So we would point out that this is probably top 3 in industry right now. So as an overview, JMS, the leading manufacturer of belt conveyors in the wastewater treatment industry. We manufacture and design to SEMA standards, extensive use of stainless steel, and individual conveyors are complete systems. And I just want to take you to, and more would be, on our website, I just wanted to point out that if you go to the website, we've got a learning center here. We post webinars and blogs on, here's a good one on shafted screw conveyors versus shaftless screw conveyors. So you'll find a number of material handling videos, articles, and basics here. It's a good resource for you. Typical would be, there is a gear reducer that, depending on the requirements of the gear reducer, I think that there's an oil change typically once a year on that. There are some bearings that need to be greased on the head and the tail pulley shafts, but that would be periodically throughout the year. That would not be wouldn't be a weekly thing. All the other bearings and the idlers are sealed, so it's fairly low maintenance. Other than the weekly visual check that you would expect to do with any piece of equipment, kind of a walk around, just make sure it's tracking well, make sure there's nothing leaking, and that sort of thing. Yeah, and that after it's initially started up and adjusted, that will have to be checked periodically, especially the first 6 months. And that, what I did briefly mention the take-up, but there's a take-up adjustment on the tail end, and that's where that is adjusted. Frequency of that, probably depends on the length of the belt. The longer the belt's going to be, the more that's going to have to be adjusted until you get the break-in period.